Today, I will present our project on analyzing football passing patterns using dynamic graph isomorphism. Our input data set consists of football match data in a CSV format containing information about passes between players. The main columns include passer IDs, receiver ID, timestamp, and match ID. These structured data set help us model the interaction between players as a dynamic graph where each player is represented as a node and each pass is an edge connecting two nodes. The passer ID and receiver ID indicate which players are involved in a pass. Timestamp provides the time when the pass was made, and match ID helps us separate passes from different matches. To segregate the passes by match, we first filter the dataset by match ID, ensuring each match data is processed separately. Next, we divide each match into time windows, for example, 1 minute intervals. This division allows us to treat each time window as a snapshot of the match. By doing this, we can capture how the passing strategy evolves during the game and analyze the flow of the match in discrete time segments. Then the match data is split into time windows. For instance, a 1 minute window captures passing data in 1 minute intervals, which helps to analyze how a team strategy changes throughout the match. The code provided by Oberoi detects dynamic subgraph isomorphisms in temporal graphs using the VF3 algorithm. It processes input as graph with nodes and edges and include edge attributes like timestamps to capture temporal dynamics. By dividing data into time window snapshots, it identifies recurring patterns over time using a sliding window approach. This makes it suitable for analyzing evolving passing strategies. The output includes all detected matches, showing how interactions evolve during the game. Now let's walk through how the project works from input to output without dividing into the code itself. First, we load the football match data, which consists of passes between players along with the timestamp for each pass. This data is then pre-processed by segregating the passes based on match ID and dividing each match into time windows. Once we have these snapshots, we can apply subgraph isomorphism detection using the VF3 algorithm. This algorithm compares the pattern graph, a model of typical passing sequence, to each time window graph. The result is a set of matching passing patterns detected in the match data, showing where the passing sequence from the pattern appears in the actual match. Finally, these detected matches are visualized as graphs. In each graph, the nodes represent players and the edges represent passes between them, with timestamp to indicate the timing of each pass. This visual representation makes it easy to see the evolution of passing the strategies and compare how different teams pass during various phases of the game.
Okay, so I will be explaining how the code will be implemented for converting the inputs into the desired outputs. So our approach can involve several steps to convert input into the desired output. Firstly, we start by loading the football match data from the CSV file using Python's pandas library, and then we do some pre-processing. That is, we plan to pre-process it by segregating passes based on match ID and splitting them into time windows. This prepares the data to be converted into dynamic graphs. And after that, we create graphs for each time window. We will create a dynamic graph using the NetworkX library. Players are represented as nodes, and passes are represented as edges with timestamps as edge attributes. Furthermore, subgraph isomorphism detection will be implemented. We will then apply the VF3 algorithm to detect matching patterns between the pattern graph representing a pass sequence and the target graph representing the match snapshot. We use a sliding window approach to detect recurring patterns over time. And finally, visualization. Finally, we will use Matplotlib to visualize the detected passing patterns, which gives us a visual representation of how a team's passing strategy evolves throughout the match. And furthermore, after detecting the passing patterns, we will analyze the team to gain insights into the team strategies. For example, frequent passing patterns, teams that prefer short, quick passes often form more passing chains or triangles which show up frequently in the analysis. Transition patterns, teams may switch from defensive to offensive strategies, which we can observe by tracking the evolution of passing patterns over time. And furthermore, we compare the teams' strategies by comparing the detected patterns. We can see that Team A might focus on quick short passes, while Team B uses long passes to move the ball upfield more directly. And in conclusion, our project provides a comprehensive approach to analyzing the football team's passing strategies throughout through the use of dynamic graph theory.